Joining us in the studio now is Larry Fortmuller, Director of Marketing with AST Research. Next to Larry, Neil Rubenking, Contributing Editor with PC Magazine. Jan?
Neil, we hear so many different elements that go into the speed. We hear about the different processors themselves, the different speeds of the processors, the caching, things like that. How do all these interrelate, and what do you use for what? What's the best thing to use?
Well, the best thing to use completely depends on the thing you want to do. If you're using a big database program, the data's on the disk and it has to be read constantly, so you get a fast disk and you add caching. If you're doing a graphics-intensive programming, you get a graphics coprocessor, and no matter what you're doing, if you get a faster processor, the computer will run faster, and each of these benefits adds to the other. So if you do everything possible, you can increase the speed of your computer just to an amazing level.
So it's more than just a question of megahertz, or more than a question of what chips in the machine.
It's more than megahertz.
All right, speaking of megahertz, that's the one part we want to focus on of the many Neil just talked about. And tell us what your setup here is, Larry.
Certainly, Stuart. What we have here is 3 different computers, each at a different speed. AST's Premium 386SX over on the left runs at 16 megahertz.
Okay.
In the center, we have a full-blown 386 chip running at 25 megahertz, and then on the far right, a 33 megahertz machine. And we've got some software that we thought we could run to show the viewers a little bit about the relative speeds and the effect that the relative speeds of each of these processors have on the performance in a real-world application. In this case, the first case here, we have an example of a graphics program and how some pretty active graphics is affected by the megahertz rating of the machine.
Let's run through this.
Okay, Jan, if you'll help out. Ready, set, go. What you can see happening here is that the 3 machines will actually operate at different speeds, and although we started at the same time, they'll quickly get out of sync because of the relative speeds of the 3 machines.
And obviously the one on the right running at 33 megahertz is now running way ahead.
You got it.
The middle guy at 25 a second, and the slowpoke here at 16 megahertz.
And they're getting more out of sync.
Is dragging along.
Right.
And as you were saying at the beginning of the program, Jen, then graphics is obviously one heavy demand in terms of speed.
Yeah.
All right, now you have an Excel demo also you talked about, in which we can see a more typical number crunching speed race, if you will. Could we get out of the graphics bit here and move into the Excel demo?
We can do that, Jan, by hitting escape. And we'll enter the number 2 this time.
Okay.
And we can start that pretty much at any time, Jan, and it'll come to a break point, and we'll get them all started at the same time.
All right, tell us what's happening as we watch this.
Okay, you know, there's lots of ways to benchmark machines, and there's no real right answer. You've got to look at the applications that you use in the real world in order to decide how you're going to measure your machine and make a common sense selection. If you're a number cruncher, if you're into Excel or Lotus 1, 2, 3, or any other numerically typical type application, then running this sort of a test will give you some indication as to what's right for you.
Do we have to hit enter here to get these guys going?
Yes, we sure do. We can do that at any time, Jan.
Okay.
Now, each of these programs will run separately. It'll iterate through some integer mathematics and then some floating point mathematics. When it gets done, it will time itself, and it'll give us a numerical indication of how fast each machine performed the test.
Okay,
now, is that one finished already?
Probably. Yes, it's finished the first half, and now it's gone into the floating point version.
Okay, so again, all 3 machines are doing the same task, doing this big crunching job on an Excel spreadsheet. When it's all done, it'll report to us how long it took each machine to do it.
That's exactly right.
While we're waiting, let me ask you, you have a 486, the Mystic 486 chip here. Tell me about this board and how it relates to your AST machine.
Sure. The folks at Intel have done some more magic with the 486 chip, and that's, of course, the latest in their cadre of chips. Each of the 3 machines here are part of the AST Premium series, and each of them has an architecture we call Cupid 32. Cupid 32 is a way in which we've been able to separate, if you will, the processor components of the machine such that we can upgrade any of these models to a higher megahertz version. In other words, the SX can move to a 386-25 or indeed to a 33, and now, of course, to the 486 chip. And it's a simple upgrade. You simply unplug one board, pop in another, and fire up.
All right, taking a look at our demo here, old 16 megahertz is just finished up finally. Now, can you show us some graphic representation of the difference in performance speed?
Yes, I believe I can. We've graphed the results here, and that'll come up in a second on the screen to your far right. And what you'll see here is that there is a curve. In red, we see the integer results, and these machines, by the way, don't have a math coprocessor in them. and therefore we're seeing relatively slow floating point results, but still the ratio is the important thing here, and we can see that as we move from a 16 megahertz that takes a relatively long period of time, we move to the 33 megahertz, things get done at a much faster
Anyhow,
clip.
isolating on megahertz and speed of the chip, we really see a difference here.
Right.